In section 8.3, we look at the conditions necessary for an atom to form multiple bonds. If you think about it, a double bond requires one unhybridized p orbital to form the pi bond. For example, in the molecule formaldehyde, we saw that the sigma bond was formed by end-on overlap of the hybrid sp2 orbitals on the oxygen and the carbon atom, but the pi bond was formed by the overlap of the unhybridized p orbital on the carbon and the oxygen. So what we're really saying is that for a double bond to form, we're going to frequently see that atoms are sp2 hybridized. So this is especially true for carbon. We begin with electron configuration 2s2 2p2. We hybridize to form 3 sp2 hybrid orbitals in a trigonal planar arrangement, and that leaves us with one unhybridized p orbital, which can engage in pi bonding, forming the double bond. A triple bond requires two unhybridized p orbitals to form. We can see this if we look at the molecule acetylene. In the molecule acetylene, we saw that the sigma bond was formed through the overlap of sp hybrid orbitals on each carbon, but the two pi bonds were formed by the overlap of unhybridized p orbitals. So for carbon, we'll see triple bonds when the carbon is sp hybridized. So beginning with the unhybridized carbon with electron configuration 2s to 2p2, we then hybridize to form two sp hybrid orbitals, leaving two unhybridized p orbitals, which are available to form the two pi bonds. So this is all very important information for organic chemistry. When you see a double bond, you'll know that the carbon is sp2 hybridized. When you see a triple bond, you will know that the carbon is sp hybridized. And if you see neither a triple nor a double bond, then you'll know that the carbon is sp3 hybridized. So just summarizing, keep in mind that a triple bond is always composed of one sigma bond and two pi bonds, whereas a double bond is always composed of one sigma bond and one pi bond, and each pi bond requires an unhybridized p orbital. That means that we're going to be seeing triple bonds when atoms are sp hybridized, and we're going to see double bonds when atoms are sp2 hybridized. Okay, and that concludes the short video on section 8.3, multiple bonds.